2017 West African Senior Secondary Certificate Examination, General Mathematics 1, Objective Test. Question number 1. Express 0.0000407 correct to two significant figures. Solution. Note that in any given number, every digit starting from the first non-zero digit is significant. In this decimal number, the first non-zero digit is 4. So, all the digits starting from 4 to the right are significant. Therefore, to correct this number to two significant figures, we start counting from 4 to the right. So, we count 1, 2. Since the next digit, which is 7, is greater than 5, we have to round it up so that the number 0 here is increased to 1. So therefore, the number 0.000407 is approximately equal to 0.000041 to two significant figures. Question 2. If x varies inversely as y, and y varies directly as z, what is the relationship between x and z? Solution. Since x varies inversely as y, we write in symbol this, and we read this as x is proportional to 1 all over y. To change this proportionality sign to equality sign, we have to multiply 1 all over y by a constant k. That is this. We write x equals to k1 all over y, where this k1 is the proportionality constant. So let us name this as equation number 1. Since y varies directly as z, in symbol we write this, and we read this as y is proportional to z. To change the proportionality sign to equality sign, we have to multiply z by a constant. That is, we write y equals to k2 times z, where k2 is the proportionality constant. And let us name this as equation number 2. To find the relationship between x and z, we have to substitute for y from equation 2 in equation 1. That is, x is equal to k1 all over k2z, and this is equal to k all over z, where the k here represent k1 all over k2. X equals to k all over z can be written as x is proportional to 1 all over z. That is, x varies inversely as z. Question 3. Evaluate 3 and 1 over 4 times 1 and 3 over 5 divided by 11 and 1 over 3 minus 5 and 1 over 3. Solution. 3 and 1 over 4 times 1 and 3 over 5 divided by 11 and 1 over 3 minus 5 and 1 over 3 is equal to, changing this to improper fraction, we have 4 times 3, 12, plus 1, 13 all over 4, times, we also change 1 and 3 over 5 to improper fraction, as 5 times 1, which is 5, plus 3, 8, that is 8 over 5, divided by 11 and 1 over 3 minus 5 and 1 over 3 is 6. This is how we obtain 6. 11 and 1 over 3 minus 5 and 1 over 3 is equal to 11 plus 1 over 3 minus 5 minus 1 over 3. 1 over 3 minus 1 over 3 will cancel out, giving us 11 minus 5, which is equal to 6. 4 will cancel itself 1, and will also cancel 8, 2. So therefore, This is equal to 13 times 2, which is 26 all over 5, divided by 6. And this is equal to 26 over 5 times 1 over 6. 2 will cancel 6 to give us 3, and it will cancel 26 to give us 13. So therefore, 13 times 1 is equal to 13 all over 5 times 3, which is 15. So this is therefore equal to 13 all over 15. Question 4. Figure 1 and Figure 2 are addition and multiplication tables respectively in modulo 5. Use these tables to solve the equation n plus 4 times 3 equal to 0. Let us study the two tables. Figure 1 is the addition table, while Figure 2 is the multiplication table. In addition table, we are adding in modulo 5. 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4. 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and 5 in modulo 5 is 0. Then you have to divide 5 by 5. That will give us 1, remainder 0. 0 is what we write here. Here, 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, and 5 in modulo 5 is 0. 2 plus 4 is 6. 6 in modulo 5 is 1. That is, when you divide 6 by 5, that will give you 1 remainder 1. So you write the remainder 1. 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is 5. And 5 in modulo 5 is 0. 3 plus 3 is 6. 6 in modulo 5 is 1. 3 plus 4 is 7. 7 in modulo 5 is 2. That is, 7 divided by 5 is 1, remainder 2. 4 plus 0 is 4. 4 plus 1 is 5. 5 in modulo 5 is 0. 4 plus 2 is 6. 6 in modulo 5 is 1. 4 plus 3 is 7. 7 in modulo 5 is 2. 4 plus 4 is 8. 8 in modulo 5 is 3. That is, 8 divided by 5 is 1, remainder 3. Now in multiplication table, we do the same thing. 0 times 0 is 0. 0 times 1 is 0. 0 times 2 is 0. 0 times 3 is 0. 0 times 4 is 0. 1 times 0 is 0. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 6 in modulo 5 is 1. 2 times 4 is 8. 8 in modulo 5 is 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And 6 in modulo 5 is 1. 3 times 3 is 9. 9 in modulo 5 is 4. That is, 9 divided by 5 is 1, remainder 4. 3 times 4 is 12. And 12 in modulo 5 is 12 divided by 5. That will give us 2, remainder 2. 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 8 in modulo 5 is 3. 4 times 3 is 12. 12 in modulo 5 is 2. 4 times 4 is 16. 16 in modulo 5 is 1. That is 16 divided by 5 is 3, remainder 1. Now the solution. N plus 5 times 3 equals to 0 mod 5 will give us 3 times n is 3n plus 3 times 4 is 12. And remember, 12 in modulo 5 is 2, equal to 0 modulo 5. But 0 in modulo 5 is the same thing as 5 or 10 or 15 and so on. But let us take the minimum value. So this implies 3n is equal to, taking these 2 to the right, that will give us 3. That is 5 minus 2 will give us 3 in modulo 5. We can then divide both sides of this equation by 3 to obtain n is equal to 1 in modulo 5. Question 5. The ages of Tunde and Ola are in the ratio 1:2. If the ratio of Ola's age to Musa's age is 4:5, what is the ratio of Tunde's age to Musa's age? Solution. Let Tunde's, Ola's, and Musa's age be X, Y, and Z respectively. Then the ratio of Tunde's age to Ola's age is X over Y equals to 1 all over 2. And that of Ola's age to Musa's age is Y over X, which is 4 over 5. Then the ratio of Tunde's age to Musa's age is equal to X over Y times Y all over Z. And this is equal to half times 4 over 5. 2 will cancel itself, 1, and you cancel 4, 2. So 1 times 2 will give us 2, and 1 times 5 will give us 5. That is, the ratio of Tunde's age to Musa's age is 2 over 5. Question 6. If M is the set of all x such that x is greater than or equal to 3 but less than 8, and n is the set of all x such that x is greater than 8 but less than or equal to 12, which of the following is true? 1. 8 is an element of M intersection N. 2. 8 is an element of M union N. 3. M intersection N is empty. Solution. Let us list the element of the set M and N. Since x is greater than or equal to 3 but less than 8, the element of the set M consists of the numbers from 3 to 7. That is 3, 4, 5, 6, and 7. And in N, since x is greater than 8 but less than or equal to 12, the element of N consists of the numbers from 9 to 12. That is 9, 10, 11, 12. Then let us find the intersection of these two sets. M intersection N is empty. Please recall the intersection of two sets is the set of common element. Since there is no element that is common to the set M and N, it means that M intersection N is empty. So that means number 3 is true. Let us also find M union N. M union N is the set of elements that belongs to either M or N or both. That is the set of the element of M and N put together. This set contains the element 3, 4, 5, 6, 7, 9, 10, 11, and 12. Clearly, as you can see in this set, 8 is not an element of this set. So that means the statement number 2 is not true. The statement number 1 is not true. It is only number 3 that is true. So, number 3 only is true. Question 7. Given A equals to log 7 and B equals to log 2, express log 35 in terms of A and B. Solution. Let us write log 35 as log 7 times 5. And since log of the product is equal to the sum of the logs, this is equal to log 7 plus log 5. But log 7 is given to be A. This will give us A plus expressing log 5 in terms of 2. We can write log 5 as log 10 all over 2. And this will give us A plus log 10 divided by 2 is log 10 minus log 2. But since log 10 is equal to 1, that's log of the base. Note that this log is given in base 10. So this will then give us A plus 1 minus log 2, which is equal to B. Number 8. If x is equal to 2 over 3 and y is equal to minus 6, evaluate x times y minus y divided by x. Solution. xy minus y over x is equal to 2 over 3 times minus 6 minus 6 divided by 2 over 3. Here, 3 will cancel itself 1. And it will cancel minus 6 to give us minus 2. This will then give us 2 times minus 2, which is minus 4, plus 6. Minus times minus will give us plus. Then 6 divided by 2 over 3 can be written as 6 times 3 over 2. Thus you have to invert the denominator. And here, 2 will cancel itself to give 1. And it will cancel 6 to give 3. So this will then give us minus 4 plus 3 times 3, which is 9. And minus 4 plus 9 is 9 minus 4, which is equal to 5. Number 9. Solve the equation 1 over 5x plus 1 over x equal to 3. Solution. The LCM of 5x and x is 5x. So 5x divided by 5x is 1 times 1. That will give us 1. 5x divided by x is 5. And 5 times 1 will give us 5. And this is equal to 3 all over 1. 1 plus 5 is 6 all over 5x, which is equal to 3 over 1. At this point, we can cross multiply. 3 times 5x is equal to 6 times 1. So this will give us 15x equal to 6. Therefore, dividing both sides of this equation by 15, we have x equal to 6 all over 15. 3 will cancel 6 to give us 2. And 3 will cancel 15 to give us 5. So therefore, x is equal to 2 all over 5. Question 10. A sum of 18,100 naira was shared among 5 boys and 4 girls, with each boy taking 20 naira more than each girl. Find a boy's share. Solution. Let each girl's share be X naira. Then each boy's share will be X plus 20 naira. Therefore, the total of the girl's share will be 4X and the total of the boy's share will be 5 times X plus 20. Adding these two should give us 18,100 naira. Let us open this bracket to obtain 5x plus 5 times 20, which is 100. So therefore 4x plus 5x plus 100 is equal to 18,100. But 4x plus 5x will give us 9x equal to, cross 100 to the right hand side to obtain 18,100 minus 100, and that will give us 18,000. Dividing both sides of this equation by 9, we obtain x equals to 18,000 divided by 9 will give us 2,000. So each boy's share is 2,000 plus 20, which is equal to 2,020 naira. Question 11. One factor of 7x squared plus 33x minus 10 is. Solution. To factorize this quadratic expression, we have to multiply the coefficient of x squared, which is 7, by the constant term, which is minus 10, to obtain 7 times minus 10 equals to minus 70. So we express minus 70 as a product of two factors, so that their sum will give us plus 33. That is, minus 70 can be expressed as 35 times minus 2. Clearly, as you can see here, that 35 plus minus 2 will give us 33. So we can therefore factorize 7x squared plus 33x minus 10 as x plus 35 times x minus 2. So the two factors of this expression are x plus 35 and x minus 2. Question 12. Solve minus 1 over 4 less than 3 over 4 times 3x minus 2 less than 1 all over 2. Solution. First, we consider the first inequality, minus 1 over 4 less than 3 over 4 times 3x minus 2. If we multiply both sides of this inequality by the LCM, which is 4, 4 will cancel here and 4 will cancel here. So this will give us minus 1 is less than, open the bracket to obtain 3 times x, which is 9x, minus 3 times 2, which is minus 6. And this will imply 9x is greater than 5. That's when you take minus 6 to the left, that will become minus 1 plus 6 is less than 9x. Minus 1 plus 6 is 5, less than 9x. And we can rewrite it as 9x is greater than 5. Now, dividing both sides of this inequality by the coefficient of x, which is 9, this will give us x is greater than 5 all over 9. Now, let us consider the second part of the inequality. 3 over 4 times 3x minus 2 is less than 1 all over 2. Again, the LCM of 4 and 2 here is 4. So if we multiply both sides of the inequality by 4, 4 will cancel here to give us 3 times this. So 3 times 3x is 9x. 3 times minus 2 is minus 6. Is less than, multiplying 1 over 2 by 4, 2 will cancel 4 to give us 2. So this implies 9x is less than, that's when you take minus 6 to the right. So that would then give us 9x is less than 8. Dividing both sides of this inequality by 9, we obtain x is less than 8 all over 9. So therefore, putting the two solutions together, we have x is less than 8 over 9 but greater than 5 all over 9.